Good morning, my name is Kayla Casassis, and today I am going to be teaching you about the early astronomers. Ptolemy, following the idea of his predecessors, believed in a geocentric theory. This was a theory that the Earth, right here, rather than the Sun, was at a fixed point at the center of our universe, and that all of the planets orbited around it like this. He also believed that the stars moved in a retrograde motion and had their own orbit around Earth. He believed that the stars and planets moved in a double motion. This was the idea that the planets and stars moved in one big orbit around the Earth called the deferent, as well as a smaller orbit called epicycle. And they moved both at the same time like this. And this was his explanation as to why Mars sometimes appeared to be moving in a retrograde motion and sometimes appeared to be moving normally. But the real reason for this is because the planets move faster when they're closer to the Sun. His idea was accepted for over 14 centuries until it was proven wrong. Copernicus was the first astronomer to introduce the heliocentric theory. This is the theory that is accepted by most astronomers and people today. The heliocentric theory stated that the Sun, rather than the Earth, is at a fixed point at the center of our planetary system, and that all of the other planets orbit around the fixed point of the Sun, like so. Galileo proved this when he discovered the Galilean moons and that they orbit around Jupiter itself and not around the Earth. This proved that the Earth is not at the center of our universe. Johannes Kepler was an astronomer that worked closely with Tycho Brahe to prove the heliocentric theory. Kepler created the 3 laws of planetary motion. The first law is the law of orbits, which states that all the planets move in an elliptical orbit with the Sun as the foci. His second law, the law of areas, says that a line that connects the Earth, a planet such as the Earth, to the Sun sweeps out in equal distance in equal times, and that the planets move faster when they are closer to the Sun. Kepler's third law, the law of harmonies or the law of periods, says that a planet's orbital period squared is proportional to its distance from the Sun cubed. This can be modeled by the equation t squared equals a cubed. In this equation, t equals time in Earth years and a equals astronomical units. 1 astronomical unit equals the distance from the Earth to the Sun. Today I'm going to be demonstrating Kepler's Law Lab, where we are going to prove Kepler's third law, the law of periods. The materials for this lab are a piece of cardboard with 2 tacks, a string tied in a loop, and a marker. First, place the 2 tacks into the cardboard like so. One of the tacks represents the Sun and the other represents a planet. Then place the loop of string around the 2 foci like so. Using your marker, trace the elliptical of the planet, creating an oval. This shows the elliptical orbit of the planet. You can apply this to Kepler's third law by measuring the distance from the 2 foci, the Sun and a planet, such as Earth, and plug that into the equation t squared equals a cubed, and plug this distance in for a to find out the orbital period time. This demonstrates Kepler's third law.